Hello, everybody. So, this is what in the 8-week classes would be starting in module 2, but remember we have 8 modules spread out over 2 weeks each this time. So we're still in the module 1 stuff. It stretches out. We have lots of time to practice with the language. The course is designed to fit, so it can be done in 8 weeks, but we're going to stretch it out, get lots of practice, plenty of time for the knowledge to sink in. Hopefully, it'll help with school can often feel overwhelming. So having one class that stretches out will hopefully remove some of the stress from the other classes. Make it feel like you're not quite so busy. But as such, after a couple classes here, I think I'm starting to get remember how much material goes in an hour and 15 minutes. Started got we got the 2-hour class and want to make sure there's plenty of time to live on that. Everything's been 8 weeks lately, so I've started to I've started getting used to the 4-hour classes instead of the 2-hour classes. But still some I guess setup stuff, some continuation things that we didn't quite get to the other day. I had a feeling we weren't going to get to them. And one thing in the syntax I want to show is the book definitely doesn't cover it. Those had me in the fall. I'm pretty sure I mentioned it because I was really, really excited when they added the Python language last October, finally, after 32 years. So we'll take a look at that and a couple other things. And we'll take a look at what I had in mind for comments if y'all saw that assignment thing. Instead of just the comments that don't do anything, I tried to set when I like to introduce the useful comments. So like in the Java class, Java doc, or in a lot of classes, my favorite of the documentation generators work with is Oxygen. D is spelled D oxygen, but I think we're supposed to pronounce it like docs, like document, but Doxygen. It knows lots and lots of languages, which originally for C++. The website it generates has an external style sheet, so you can just keep a style sheet around and swap that out. Make it really easy to make it look the way you want to. But for our documentation generator, I did choose one that is Python specific for us to use. It does the style, the HTML styling in line. So to adjust it sometimes takes a little bit more work. You can put an external style sheet on it. But basically, I just wanted to look at the documentation generators instead of comments that don't do anything. And see those. I like to look at those at the 200 level. That way you can get started practicing with really good documentation, useful documentation that people will look at. Is when somebody's using a library or package or module that you wrote, they're not going to dig into the code and look at the comments you put in there. They're going to go to the website documenting it. So might as well get started practicing that now. An issue about the manifest, we saw pip freeze the other day that shows everything that's not part of the default install. Then we can just copy and paste the ones we need. But when we import something, we write that in text, in Unicode, in the Python script. And I'm pretty sure everybody in SDEV 140 class, or at some point before this, in your early experience to Python, have done things like parsing the text in a file. So if we import a module into a Python script, it's nothing to look at that Python script and parse through there and figure out what modules are imported. So we don't have to dig through the whole list ourselves. So I brought in, I picked a nice module for that part of the manifest. We'll look at that and at least one note on syntax, because it's definitely not in the book. It was only added in the Python in 3.10, which was released in October. But we can go ahead and get started. Just a few things. And again, I think I'm getting starting to remember how much material fits in an hour and 15 minutes. It's been a couple years that all the classes I was would be trying to do 2.5 hours of material. So I'm gonna sign in for my MacBook, or at least the start of the example today. Probably most of the day, because this is the one that has Python 3.10 on it. What was that? Yeah, Zoom is not happy when you try to join without explicitly not connecting the audio. So another point, this class stretched out so we can make little points along the way. One of the nicest things about Python is the cross-platform. Python and Java, those are our two main cross-platform languages. We write the same code and it runs on any of the machines the same. Y'all noticed the other day I jumped between the PC and the Chromebook. The ninth going to be on the Mac. So the same code runs on all of our systems. It's really nice about Python. That's not necessarily the case in all our languages. I still like to test it separately. They're not fancy machines. These machines are pretty much the cheapest ones at Walmart. My MacBook I actually only have that because it was on the clearance rack at Walmart because of a little bitty scuff mark on the back of the plastic piece that goes around the actual laptop. I don't really want to call it a protector because it's a soft plastic wrapped around the stainless steel Mac case. So it's not protecting anything, but there was a scuff mark on it and that made it $300 off a brand new Mac. So remember to check clearance racks. It can be very useful, and even though it's cross-platform, should be doing the same thing. It's still good to test on multiple systems. So at least maybe look into VMbox or something where you can run virtual machines and test your software in a couple different systems and make sure it works the same. Python is really, really good about that. It runs exactly the same on all the systems, so it's usually not much of a worry there. The GUIs might look a little bit different. You don't want a GUI that looks like it belongs on a Windows 10 machine running on Ubuntu. Right? That's going to look out of place, or vice versa. But that's front end stuff. The back end stuff all consistently works the same. So the first thing I wanted to look at, I kind of alluded to this the other day, but didn't explicitly state it, is we can have multiple Python environments. We looked at environments, but you install Python, install it. There's multiple ways to get to it. In terminal, you probably have, most everybody in here probably has some sort of IDE set up. There's Python, so it's going to at least have the idle IDE. Oh, speaking of IDEs, little side step here for a second. I was looking at some articles and stuff today, and VS Code, Visual Studio Code, they started yesterday, I believe, releasing all of the things they plan to do for 2022. The Visual VS Code roadmap for 2022. And remember, there's that new technology report due. And I believe at least one person in here said, maybe two. One or two people said they were going to use VS Code for their main IDE. So if you're doing that, that might be a good one to look at for your new technology report, because those new features are going to relate right to the IDE you're using. So learn more about your tool or where your tool's going, and knock out that paragraph or so for that technology report really quick with that. I believe it started yesterday, then today the job one came out. It's probably going to stretch out for a while because VS Code is kind of a big project, but just something to think about for that new technology report. Okay, so back to that little side note. So we looked at environments, install Python, the operating system knows about it. We can run it from one of our operating system control terminals or the IDE, a notebook, different environments. Those are called Python environments. And we can have more than one environment. It is definitely not a restriction. And open my MacBook to start here to kind of show this. So if I just type in the Python command, it's a Unix system, and part of the Unix kernel, as it currently stands, was written in Python 2.7. So Mac and Linux machines still have to have Python 2.7 installed. So you can see it jumped in the interpreter, and as it starts up, Python 2.7.16, a really old one. Probably don't want to use that one. So I'll exit out of that, clear that. Instead of Python, I'll type Python 3. Oops, there's no D in that word. So you can see it opened up 3.7.9. I installed this over the break because my favorite machine learning library to work with is PyTorch. That's the one Facebook built. That's Facebook's machine learning package library, algorithms, all the code Facebook put together for machine learning. It's called PyTorch, and they've updated it, but because of some changes in Python that were mapped out over several versions, they haven't. It's a background release on everything after 3.7.9 because you have to customize your highly customize your installation of Python 3 point something until I think later this year. But I had to roll back to do some stuff with that library. I had to go back to 3.7.9, so I installed that. So you can see there's two versions of it. Or if I exit out of this, I can type Python 3.10. And here's Python version 3.10. It's at least two of the middle numbers later than the version there at the top of the terminal, right? 3.7, then there was a bunch of 3.8s, 3.9s, and 3.10. When I was installing one in the office earlier today, or I can't install software on the computer in my office, but when I contacted the IT department to install Python in the computer, the desktop in my office, it was 3.10.2. Python pretty much updates every month. 3.10.0 came out in October. Then one came out at the end of November, and 0.2 came out at the end of December. So sometime this week, I would expect 3.10.3 to come out. But you can see there's multiple versions there. And then new features do get added, old features get deprecated. So it's important to keep track of which one you're working on. And these are actual environments. Python also has virtual environments so that we can do a little fake version. Right? If we have 3.7, we could install a fake version of 3.4 to get to an old deprecated method if we wanted to temporarily. Those are called virtual environments. We'll look at those later. Or you start with the real ones. And I just opened the terminal here to see which language we are. We do that. It's a really useful one is if you need that version number, you can get it from the system library, SYS. So import sys and then sys.version will tell you what version you're on, release dates and all that stuff. And while the system library is here, another very, very useful one is .path. So this is where the Python interpreter looks for the modules it's going to run. So the first place it looks is going to be in the same folder you're running from. And so y'all have seen where I work at on my computers. I have that in the documents folder. I keep a folder called delete, and that's where I do all the work at, and then copy it someplace later. So over in my delete folder, when I put together a script and then go to run it, if I import a module, the first place it's going to look is in that delete folder, the same folder it's in. Then it's going to go over to where the library is installed. So here's where the installation is at. We saw the installation on the, I think on the PC the other day. So the address looks a little bit different here, but that's where the Python language is installed. So obviously that's where the interpreter is going to go look very, very quickly to see if something is, if that's where the modules we want are, where the actual Python library is installed. And you can see this list of things it goes through, of different places it looks, but it's a list. So like if you're developing a big package, has lots of different modules organized in different folders, keep everything straight. And you want to, and it's part of your thing, so you want to make sure that the computer knows which place to go look for modules. We can append that. If you see from the printout here, path is just a list. So all we could just do dot appended in, or for that particular case I just mentioned, since I know where the modules are going to be, I always use insert instead of append. So I could say something like sys insert at index 0, make it the first one, very first thing. So look here first, since I know where the modules I want are. I don't know, I'll do slash in slash dash. Not really going to run this, do this line. We'll probably see that later. Oh. Zero. And then it's an address, so it's a string. It needs to be a string. As always, addresses should be a string. Oh, whoops. Sys. Let me try this again. Clear all this out of here, and then go into Python 310. So we can import the system one. This would be another way to run pip, because it is system as far as the system that is the operating system the machine is running on. So sys.version will be useful because I did ask for that number. Please make sure you let me know which version of Python you wrote and tested your scripts on, your homework and your projects on. And sys.path is where it looks, but that's a list. So let's see if I can do it correctly this time. Sys.path is a list, so we can insert at index 0, a place where we know that that's at. So I don't think it's going to work. There we go. So now if I do sys.path, you see that the first place it goes and looks for modules is that one. That can be really useful, and I just did it in the shell prompt here. Obviously, that's something you would do in your script, like the very first line. Import the system module, adjust there where Python interpreter goes to look for modules, and then import the rest of the modules once you got it where it's at. But the main thing I wanted to point out there is that there's nothing wrong with running multiple versions, multiple Python environments on one system. And there's really no trouble with it whatsoever, as long as you see that naming pattern. Do y'all notice any sort of pattern to that naming? As the version got later, I had to add more details to it, right? So the earliest version installed on your system is Python. And then if there's a subsequent one, then the second one, you add that first, the first number that's, yeah, the version numbers first, so the 3, and then the release number, and then the patch. So we add them in that order. So if 2.7 wasn't here, that's necessary for Unix. So like on the PC, where we don't have to have version 2.7 out there. When we say Python, it's probably referring to Python 3.7. If you have multiple versions, Python would refer to the earliest versions of Python installed. And then the next one you can get by with just the version number. And then after that, you have to start adding more and more details in the version and the release number. So Python version 3, release 10 in that case. Just kind of showing you that because at some point in the future, it'll probably be useful to have multiple versions of Python around. For our class here, you're probably just going to pick one and work with it the whole time through. And our IDEs can also handle that. Have I asked what systems people are using? Excuse me. Oh, have I asked what systems people are using? I like to show the keyboard shortcuts if I can. So on the Mac, when I was in terminal, I hit Command W to close the windows. Everybody's a Mac user. You probably knew that one. Command W, close that terminal window, and then Command Space, kind of the two easiest buttons to push on the keyboard because it's just mash your thumbs down together. Command Space pulls up Spotlight, which is a search the local machine. That's so much easier than any of the other command shortcuts on Macs. Okay, I'm gonna close this out this time. Go back to the regular Untitled file. So I'm just opening up the IDE here. A couple things we didn't look at the other day. We looked at a few basic points. And Spider is my favorite IDE, but anything you use that we would call an IDE should have these same features. Notice right off the bat, there's some code here to begin with. Up at the top, there's a shebang. You haven't encountered that before. Very, very common in Unix systems. Really in Linux systems, we don't use it much in Mac. But a comment, like the quiet thing, and then the exclamation mark, like exploding sort of thing. So that's called shebang, is how we read that. And it says where to look, tells us where to look for the language that it's running in. Then there's a comment saying Unicode 8. Then a couple other things. Today's date, which this file was just created, it hasn't even been saved yet. So obviously I didn't type that date in. That has to be coming from the computer somewhere. my name, and then I like to include which version it is. And all these things are customizable. So on a PC, if you're in a Spider on a PC, you probably have a preference, a menu that says preferences or something like that. I think it's under tools. I think it's under tools, but I'm on a Mac, so I have the preference menu explicitly. It's put somewhere else. Oh, whoops, not Mac. The preferences is going to be under Spider. But if you're on a PC, it'll be over here somewhere, or Linux system. Somewhere there's the preferences for the IDE. And you're going to spend a little bit of time on whichever IDE you're working with, whatever your main one is, looking around at some of these things, customizing things. They're all fully customizable. Do I have idle in here? Surely I do. Okay, yeah. So just on the basic one, under idle, again, on a PC, it's over under options, but on a Mac, there's that preference one explicitly. If you go to options, you'll see all the customization things, the colors to make it, the keys, and set up templates and stuff. That way you don't just start with a blank file. That was one of the first things I wanted to talk about. First thing, I moved this back to 3.7.9 over the break to work on a project specifically. For this class, I'm going to use 3.10. So to change that, is just like in our main terminal, we can have more than one system. Under preferences in Spider, you'll see something for the Python interpreter, which Python interpreter to use. Obviously, it might be labeled different in different IDEs, but you will still have that feature somewhere on there. You might just have to look around with or check some documentation on Google. So right now it's pointing at the 3.7 on here. So I can just browse to a different one and choose that. So I can go in 310 and try to remember which one of these I'm supposed to choose. I think it's a bin. I think it's this. Let me see if this works. Last time I changed it, it took with 3 or 4 guesses on the Mac. Because on the PC, if you're on a PC, you just want to point to the Python interpreter, which is the file called python.exe, the executable file. A whole lot easier there. Now if I restart this, it should have updated the language. Oh yeah, it does take a restart. And most IDEs will have a restart button on them somewhere as well. I don't know why I didn't do that, but closing it and reopen it has the same works, just like the button. Don't check credits. So now we can see over in the console, it's version 3.10. Or once again, just quickly import the system library, abbreviated as sys, and just check sys.version. Make sure that updated to the right version. Yeah, so now it's on 3.10. So my template's showing the wrong thing. My template's still saying 3.9. So somewhere in your IDE, you might just have to look around for it, but also it's really good to look around on that. That's a great way to learn a piece of software, just take a little while to click around on things and figure out what they do. Because as you look for the feature you're actually looking for, even if you don't memorize everything along the way, you'll see that a lot of the labels out of the corner of your eye and things like that. So you won't be as lost the next time you come and look for something. Or come up with a good method for finding things. So I know where this is, but I'll go through the methodology. It's like, okay, there's a lot of tabs here on the left. I'm looking for a template. Appearance, that's probably just colors and things like that. I don't need colors. Completion? Template might be on a completion, but that's probably not the first place I would think it would be. So let's keep looking. Template could be a file. Because a template is a new file, so look here, show hidden, single click. Oh, actually, yeah, this looks like it's all about the that file browser or the file explorer that comes in this IDE. So that's not going to be it. Help menu stuff, console. I don't think the template has anything to do with the console because it's over in the editor. Oh, so wait, there's an idea. So if we scroll down, is there an option for editor? Yep, way down here at the bottom. I just kind of develop some sort of method to look for stuff. So here in Spider, it's under editor. Again, it's going to be different in every IDE, but somewhere you should have a place to set up a template for new files. That way you don't just start with a blank file every time. We look through here, source code, run code. Oh, in Spider under advanced settings, there's a great big thing to edit the template. So here's a template file created on, plugs in the date. Got my name there. Version is 3.10.0. I probably installed that the day it was needed. Oh, and on the homework, I did ask for a specific header file. So while we're here at the template, might as well look at that and make sure everything matches up with what it's supposed to be. And you can see the template is just another text file stored somewhere. So whenever you go create a new file in Spider, the stuff in the background just goes and reads that file and throws that into the new file to begin with. So something easily changed. If we go to Ivy Learn, I can check what those requirements were for the template, or what would be good ones for the template. This class. And somewhere in module 1, I think I talked about it in module 1. It's been a few weeks since I wrote these things now. Here. Oh yes, comments and dependencies. I think this is the things we're going to talk about this evening. Yeah, so instead of the comments that don't do anything, we're going to use this. We'll look at that here in a second. And here somewhere. Yeah, what we're getting to here in a second, there's a picture of it. That line right there creates a website. This picture down below, y'all probably seen that by now. Okay, so here's what I asked for in the header comment. So that sounds like a good thing to start out every file. That stuff in the template probably not hard to have there right now. How it's encoded. If you change it, definitely please let me know you went to a different encoding. Otherwise, I won't be able to look at your code. I'll need to know how it's encoded in order to open the text file. Because Unicode isn't our only option. That's just the big one. That's the main one. But there are other things to use. A couple years ago in Java class, somebody for the final project wanted to do something that related to the machines he used to work. And those machines were German machines, a really big German company, and they did their own encoding because they didn't need all of Unicode to set up the text files for that. So he had to do his Java project in a custom encoding that neither one of us had ever heard of before. But the company whoever made the machines, they decided to come up with their own way to encode the text for the programming language instructions. Just to minimize stuff. They only use this, that way they stripped it down even smaller than ASCII code. Like, there was less than 100 characters that they actually needed to write every instruction for that machine. So they only encoded that many. So it looks like name, some sort of file name, a date, and then the version of Python. So should be really easy to set that up. So what did I say? I'm going to go ahead and keep the notation. The annotations. So I'll put my name up there. Then I'll put a line here that says insert title here. The date, the version. That'll work. So now just save the template. And whenever I create a new file, it has the appropriate header stuff for this class here. And when you're out after you finish school and get a job developing software at some company, there's probably going to be a specific header file you put for that company. Just throw it in the template. In that case, they probably give you the template to start with. Like, yeah, here's we'll email you the header file to start with. So now this is ready for any of the class projects. Just throw the name in there, and that criteria is already met. Not something that has to be done repeatedly. Whichever IDE you're using, you should most definitely have a way to set up a template file. If nothing else, shouldn't be too hard to make a template file, right? Even if you're using a text editor, just save a text file with that basic stuff in there. Or you could write a script that inserts that stuff in the text file. That wouldn't be very hard either. I think most of y'all probably know enough Python to write a text file, to write a small function that would do that you could, and make your own new file function. That might be great Python practice, actually. To say that aloud, that might be better practice than just adjusting the template in the IDE. Give that a try. When we get to file writing, which I believe is module 2, we've still got a few days on module 1. But when we get to the file writing chapter, see if you can come up with your own template method that might work better than that. Gives you a really good starting point with all those things. But any IDE should have that functionality in it and should be customizable and stuff. But even a text editor, you could save a text file and just call it template, so that every time you go to make a new one, just open that and then do save as and change the name, give it a new name, and then it's ready to go. It's not like templates are hard to make. And it simplifies a lot of processes because then you only have to do some stuff once. Okay, so while we're here, something that is not in the textbook, I believe those had in the fall for SDEV 140. Already saw this because I was very excited when it was finally added in. In most of our programming languages, along with our if-else structures, that was in the module 1 chapter stuff, so let me write some stuff on the board. Everybody's seen Python before. We talked about that. So you're familiar with the if, else if, but Python has significant white space, so we can't have else if it's 2 words. And they went with easy everywhere, so they abbreviated LSIP down to 4 letters with no space. And then finally an else. I think I mentioned again in this class, so there is sort of a Python format of Python syntax that I like to point out. I've probably seen it before. We have some keyword, and then we have the situational part, the thing unique to our situation. Then a colon, and then we indent everything inside of it. Right, so in this case, if, and then our situation is a condition goes here. Same thing with the while loop, while a condition goes there, or a function. In that case, it'd be def for define, but the keyword, and then the situational part, which is going to be the name of that function and any parameters that function needs passed in order to run. The keyword, unique situational part, a colon, and then we indent stuff. That's what I feel is the basic format of Python. So mention that a few times. But I assume everybody remembers this, right? If, else, they'll show up a lot when we're programming. So if you've seen some Python before, you probably have to do it a number of times. And we have different conditions, and not just in Python, in most of our languages. Is x less than 3? If not less than 3, is x, that's not less than, is x less than 3? Then we'll do some stuff. Well, if it's not less than 3, is x going to be bigger than 17? Another question we might ask. If that's true, we'll do some other stuff. And lots of different conditions we can have, ands and ors and nots, and probably do a recap on those quickly next Tuesday. But there's another thing we could check, and that would be, is x exactly equal to 3? Or is x exactly equal to 17? So it's not the case in Python, but in some languages, checking that exactly equals is notably faster, considerably faster than checking the inequality. I want to go down a little, yeah, might as well. So if you remember back to your early intro to logic course, learning about binary code and spending some time on how machines do math, first learning computer logic, you might remember we talked about the basic integers, and then went to usually a bunch of other things, sine and magnitude get mentioned, and one's complement, but eventually got to two's complement, the thing that machines actually do. We run two's complement through an XOR and an AND gate simultaneously, and that gives us addition. Actually, the way it's usually wired, it gives us subtraction as well as subtraction by the negative, which gives us addition. And then we build all of our math from there. So the two's complement is what machines actually do. I'm going to use add because that's better for humans to think about. It's actually built up from subtraction, which is a relic. Is nowadays it doesn't matter. But if you think about pictures you've probably seen in the history book, those old room-sized computers, and actually the computer was always never bigger than about a desk. The computer was about the size of a desk. The radiator was the size of a house because it took a lot to cool down all those heating coils melting mercury for those early machines. So it's the radiator that was big. The computer was a pretty good desk size. But back when computers were that big, those heating coils melting mercury, like I just said. So if something went wrong and we were adding, then that means we were turning on more heating coils when something went wrong, which becomes a fire risk. If we subtract and something goes wrong, then we're turning off heating coils. So much less of a fire risk. So the way machines actually operate, it's built up from subtraction, not addition. So when we talk about it, that really stayed around through once we got to transistors. There was no real need to remodel everything. But when we talk about it, we usually say addition because that's the way humans think about it, right? We think about building all our math up from adding. Adding becomes multiplying. Adding the negative becomes subtracting. Subtracting repeatedly becomes division. But we could just turn that 180 degrees and it all still works exactly the same. Just makes more sense to humans when we talk about adding, and only electrical engineers really need to know that fine detail. But that's what machines are doing. What they actually do, they run two's complement through an and and an XOR gate simultaneously, which I'm going to go ahead and say addition, just because it's better for the human mind. So they run those two and add numbers. Where's this come from in addition? Where's the comparison come from in addition? What did I have up there originally? Less than 3 or greater than 17? So maybe there's a 5. So x is assigned to 5. Actually, I'm going to knock this off. Bigger than 14. Less than 3, bigger than 14, and x is assigned to 5. Whoops, it is a 0. 0, 1, 0, 1. So how all we have is addition. How does it compare to that? So to compare to 3, what the machine actually does is just subtract those. So yeah, 0, 0, 1, 1. And then we'll subtract 5. 0, 1, 0, 1. And to do that, we do the host two's complement thing. Flip these bits, add 1. You'll probably remember that. 1, 0, 1, 0. When we add 1, we get a 1. And then we can add these things. And now we have subtraction. 0, carry 1. 1, carry 1. 1, carry is no carry. We have a 1. And we're not carrying anything. But that's what the machine can determine. So what the machines actually check is machines only check for false. There's 2 things. When we add a column, we get that carry bit, right? That's it. The XOR adds the column. 1 XOR 1 is 0. And the AND bit carries. 1 and 1, we have a carry. So that's how the adders work. So when we get to the end, to do the comparison, there's 2 things we can check. We can check that carry bit, or we can check if this is all zeros. Translate back to English, what the machine really checks, the machine only looks for false. So whenever we do a comparison, in any programming language, we have false, which is all zeros, or everything else. Statements are either false or everything else. To get greater or less, we look at the carry bit and see if there's a 1 or a 0 being carried. That's getting into details. But what we're really looking at whenever a machine does a comparison is it subtracts things. And if it's all zeros, they're equal. If it's anything else, we have to check the carry bit, which then we have to actually distinguish whether we have a 1 or a 0 in that carry. If anybody's going under a 4-year degree, you'll study this See this some in assembly language, but this is getting a lot closer to electrical engineering. Even is more at the electrical engineering level. So this being all zeros is several steps shorter than determining what we have here, than checking to see if we have 1 or 0. Here, just check if we have a 1 or a 0. We have to do this whole process again. It's 3 steps long. It's a whole lot more to write it out on the board and say it in words than it is to put it in the machine. We have to connect 3 wires together to do the carry bit, and we're already at the checkpoint if it's all zeros. So if they're equal, it's faster for the machine. So in most of our languages, we took advantage of that with a structure called switch. And then we look at all those zeros that are there, and we just look to see if that switch is on or off. If the switch on some number, we're going to look at X, and there's several things we want to compare to. So one of our cases could be a 3. Case is 3, then we do some stuff. The other one we're concerned about is a 14. Then maybe we compare the 14 and see if it's exactly equal to 14. So whenever we have exact equality, two equal signs or 3 equal signs. I don't think we have 3 equal signs in Python. I'm going to talk about that. 3 equal signs is type strict as well. So like 1 can be used for true. So 1 is equal to true, but 1 is an integer and true is a Boolean. So they're not strictly equal. That's 3 equal signs. But this can be quicker in a lot of languages when we're closer to the machine level. But as such, since that's quicker, since we're just treating that comparison as the actual on-off switch that it is, this can be a lot quicker, so it's available in a lot of our languages, but it's never been available in Python because well, Python's not faster about anything. It's easier. But that's available in a lot of our languages, so programmers are used to it. And in version 3.10, they finally added a version of that in. So it's not in the textbook. I want to make sure and show it. So when you have exact equality, we have what's called a match case. So I'll say X equals, I don't know, 5, some number. And then we can use this keyword match. Did I like that? Let me get that to pull up. Huh. I thought I'd done that in here before when it's on Python 3.10. Okay, yeah, it's working there. Great. For some reason, the editor isn't detecting it. I guess because it's brand new. So we just type the word match and check the thing we want to match to. And then we say cases. So like case 3 will print It's a 3. Well, that's it. That's all 3 correctly. Case 5. Here is Cinco, just to have something different there. Case maybe 7. Print 7. I think that's all I do on the case. I haven't used it very much because it's brand new. I'll stick this somewhere to work with. Here, my documents folder, the delete folder. Sure, it doesn't need a name. I was quickly showing the syntax. There you go. So it's, you see it matched exactly 5. Which the other stuff's gonna be in the book, and you've probably seen the if else if before. But when we have exact equality, in a lot of our languages, switch cases are quicker. And in other cases, they just added the notation in, similar notation, because programmers get used to it. And people have been begging Python to add that in for decades, because it's a common syntax across the board in programming languages. And they finally added it last October. So you have to be on 3.10 or higher to use it, which right now or higher only goes up to 3.10.2. But it's very, very useful because a lot of times we do want exact equality. But it is not going to be faster. We definitely don't get the faster thing for Python. Just the syntax. So that's there. And otherwise, most of the updates over the past 2 years since the last printing of the textbook are very, very advanced things that don't really show up in a getting started with Python textbook. So what that was called, what was the name? Don't show up in one of the annual books. Introduction to Programming using Python. Anything with that words like that or getting started. Most of the updates in languages are a little beyond that, but this is sort of a basic element. This is one of our selection structures. So if you have exact equality, you can use this syntax right here. Just match to some variable, and it'll only work for exact matches. Oh, and when you get to the end, just the word default, print, it's not here. It's not in this list. So then if we had like a 6 and run that, oh, maybe it's not default. Well, y'all know the routine. We'll go over it here. If you're trying to remember something, we can quickly check the syntax. Match case in Python. Oh, blog came up first. I don't need to read all this. Oh, that says it is the word default. Did I just spell the word wrong? And there's lots of blogs and tutorials. Those who have had me before probably heard me say over and over again. You always want to look at the official documentation because it's always going to be up to date. Like the python.org is the official documentation, but it's also really hard to read. So as you get used to it, use those tutorials and blogs and things like that where it's formatted really nice with pictures and everything. Use that to learn to read the official documentation. Because the same person wrote the documentation or the same group of people wrote the documentation. They worked together on it as a project. So it's going to follow a pattern. So once you get started getting used to reading it, they'll all follow that pattern. Shows up 60 times. There it is. Oh, case underscore. That's what it is. Case underscore should be the default. There we go. See, it's not in the list or 3. It works for exact equality as an alternative to if, else if, we're in Python. If, elif, 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 elif. You're going to have a whole bunch of elifs that are all checking exact equality. Not necessarily comparisons. So that's not in the book. And any other changes in 310 were probably not showing up at this level. Probably not showing up at the 200 or 300 level. They're much more advanced in the language. Probably not showing up in the classroom at all, but showing up for the people that have just used Python for their daily job and need some super advanced features. So that one's new. I would be very, very happy to see that in the homework. Keeping up on new technology, new changes. Right? That's much newer than our textbook. It takes a minute to print textbooks. They have trouble keeping up, and that can be very, very useful, especially if you've worked in other languages. Do you have anything else about the syntax? All right, so I guess we finally did something in Python, right? I wanted to do at least one thing in Python. Next Tuesday, this is a Tuesday-Thursday class, we will go over some Python. We'll be doing stuff in Python. Just a couple more things here over the last 10 minutes. Join a meeting, so I need to get the numbers. Once Zoom comes up, I think I need to replace my PC. It's getting slower and slower and slower. Probably do it. I might try to do a factory reset this weekend. I do try to do pretty much everything on the cloud, so it's not really a problem to reset the computers. So maybe that'll help speed it. Have I really open? Oh, no, I closed it. Okay, maybe I can just pull up iRelearn that over there. Nope, don't use audio. Nope, don't use audio. Okay, so the other thing, well, 2 other things. I was thinking take about 5 minutes on each one. Is whenever we go to customize our installation of Python. So briefly the other day, I'll be using the preferred install package. Anaconda is an incredibly powerful and popular one. I wasn't going to use it in class. I was just going to stick with the official one from Python. So official documentation mentions Anaconda, so they really like it too. But I will stick with it, which is preferred installer package. That's how we customize our version of the language. I have to wait for a second because I didn't give any instructions. So we just type the word, we get basically the help menu on how to use it. Normally we're going to want just a couple of them. Install, uninstall a package, and you'll notice there's not an update on there. If we want to update a package, we just run install again. Typically, probably somewhere near the end of the semester, I'll show you how to grab a package off GitHub. That way you can always keep up on the latest version of something if you want to, without having to do all that. But usually we're going to install, we're going to use pip to install and uninstall stuff. So what's something I could install? Pip install Python. That's a good example. I'm pretty sure I have it on this machine right now. I'll be really surprised if I don't have Pygame on my machines. That's taking a long time. Okay, so look in there, requirement already satisfied. Doesn't need to update it or anything. What's another one? What's a module I don't have? Install. Sure, we have pandas on here. There's an S or I'll try it. Can't remember if there's an S. I think it's pandas. Oh, there we go. So notice what it does first. Downloading it, preparing metadata, requirement satisfied. Requirement already satisfied. Requirement already satisfied. So when the module was installed, we said, okay, requirement's already satisfied. It's already there. So that once. But then I didn't have Panda on here. This is something for cleaning up, working with lists, working with data. It's got a bunch of really useful tools for working with data. We'll probably look at it later. But notice that requirement already satisfied showed up 1, 2, 3, 4, 5, 6 times. It's like it didn't do the same thing 6 times. So what it was doing there, does anybody have a guess as to what all those requirement already satisfied listings there are? Because after it did that, it installed Panda, so it wasn't referring to Panda there. Any guesses? And so at the end, it installed it, so that can't be what those requirements already satisfied for. What that has to do with is Panda is a Python library. That's a bunch of functions and objects and static data fields and things that were already put together in the Python programming language that we can import into our modules and use. So as such, they would have installed or imported some other libraries to use. Right? They probably didn't just use that basic Python install. They probably the first few lines and quite a few of their scripts in the Panda package is probably import some module or another. Import math, I can just about guarantee is in there just for cleaning up data. So they're definitely going to need a lot of math functions, right? So that's what all this is. When it went to install it, it had to check and make sure the things it needed were there. All the libraries that Panda depends on. So they were, it looks like it didn't have to install any new libraries, but sometimes it'll install several things before getting to pip, the dependencies. And that's the requirements. So what those are, we can see if we just type pip freeze. This command right here tells us every module that is not part of the default installation on Python. So whenever we create a new package for other people to use, we want to make sure they know everything that's not part of the default installation. So we can do that and copy that from that list, or there's a way to abbreviate it down. But basically, when I said pip install panda there, it called freeze in the background and checked those lists against a text file present in that package. I have one on the GitHub here. Really easy thing to work with. Hopefully it's not going to take too long. But it's part of the manifest. So remember I said in Python they went with easy and pulled the easiest section from several different things in order to get a really easy manifest to work with. Usually we just stick with one language, but they mixed them here. So we're working with the official recommendation on from Python about what to use for the manifest as far as pip. We need a file called requirements.txt. So it does all of the dependencies, everything that needs from a sequential text file. And it looks like this. So this was just an example testing. I didn't delete it yet. So one of the files in this package, in this folder right here, required scikit-learn in order to run. So this goes in to get installed, scikit-learn has to do that. So that's part of the manifest. So whenever we're working on stuff and building things, we need to include the manifest. And there is a way to do this. I'll go over to a working folder, anything in there. So testing 123.py. I'm in a hurry, so I'm just going to do this very, very quickly. You'll have seen Python syntax before. So the important thing I want to note is I'm going to import something. So I just brought in pandas. So I import panda. Import matplotlib pyplot as plt. Import pygame, that's on there. Import random, import mat, and I don't know, I'll print hello world. So all I was concerned about here was the import lines. So math and random are definitely part of the default install, but those others aren't, right? Oops, I'm in VI. So colon, right, quick, there we go. So now if I run that, Python testing 123.py. No, I just imported that. I must have made a typo somewhere, so I'm just going to delete that. There's a pandas. Let's see if that works. Well, I just installed that, so I'm not sure why that's not working. So I'm just going to take that one out of there and see if the others work. Okay, I must have been thinking about a different computer because I know some of those things should have been on this machine. Which is now quit working on me, so I'm gonna go back to this machine. Yeah, I think I need to do a factory reboot on that PC. It's been getting slower and slower and slower. And that one was a problem. I'll close Spider. Is it gonna close? I was working on it. I'm working on it this semester. So I have these things, import pandas. Oh, okay, there's at least something. So import Pygame, import math, import random. And that was great. So if I save that somewhere now, like in the delete folder. I'll make a new folder and save it here. Should run without any trouble. Yeah. Get that message from the import and the message from that. But the thing I wanted to go to had to do with terminal. So I'll open that up. So everything involved in that project, which was very, very trivial there, is in this package. So I could, to figure out what those modules are, just do that pip freeze command. Oh, whoops. I'm on the Mac, so it has to be pip 3, not just pip. And figure out which ones I've used and copy and paste them. There's another, oh, not there. 3. So there's a little library here we can install with pip. And notice this one does not have the dependencies. So it didn't say requirement already satisfied. It went and downloaded a bunch of stuff. So I run that, says it's saved successfully. And now there's a file called requirements.txt. So this is what this is part of the manifest. Needs to know all those dependencies. Everything, every outside module that's not part of the default install that we need in order to run the package, we just list out as a sequential text file. But if you install this right here, just do pip install pitrex, then navigate to the folder for that package, and then that's a single command, doesn't make any parameters or anything. It creates that file. We're going to open that at requirements.txt. which once the text editor opens, there you go. You see, I imported 3 modules, Pygame, math, and random, but math and random are part of the default install. So that's going to be anyway. And this is part of the manifest that pip runs. We saw earlier where the software was already installed, or everything that was what was going to be installed was already there. So we just needed that last step. Or when I did piprex right there, you saw the PQDM. That's a really nice one to have. You want those meters in your thing. It's pip install TQDM. TQDM. I have no idea what those letters stand for, but that's the meters in the console. Definitely going to show you all that one when we get to loops in module 2. But that's all that's in that part of the manifest that the pip, the preferred installer package, needs when it installs stuff. So I did ask for this. I made a comment even in module 1 where you're probably not importing anything, and the requirements.txt is just a blank file. Because the parts of the manifest, the language itself wants to see them there. We can get by without it, but if we're making something nice that somebody else is going to use, the manifest needs to be there even if it's empty files. Except for an example, one part of the manifest is the file called init.py. And except for an example that shows what to do with that, specifically put together so that it's something different, for this class, that's always going to be a blank file, that part of the manifest. We use that to filter out the things we don't want the user to be able to access when they import a module. But this is the first one. So it's quite easy if I can get back to this. Just pip install piprex and then go to that folder and just run that 1-line command and it will create the requirements.txt file for you. Super easy, but usually there's not a lot of imports, so it's not hard to copy. I guess one thing to note, it will always do equal to, and it's a comparison, so y'all should be able to figure out pretty quick that greater than, less than, greater or equal, less than or equal, not equal, they're going to work because it's just a comparison. But piprex will always do equal to. Just to note that. The other one went longer than I meant to there was PDoc. And in particular, we want PDoc 3. So this started, somebody started working on something, they didn't quite get it finished. And several years later, somebody else noticed it. So they branched off their GitHub and created a 3, because at that point Python had moved on 2 point something to 3 point something. So they just added the 3 on at the end. And it's a documentation generator. So when you install this one, so the original PDoc, if you did pip 3 install PDoc, that would install the original one, which was never quite finished. Or it worked, but there were still a whole lot of ideas that didn't get implemented before they moved on. So make sure you do pip install PDoc 3 to get the documentation generator. And then the command for that is just PDoc. And basically all we have to do is say where we're it'll just create a big HTML file. I put the instructions on IvyLearn. I'll pull those up real quick. Hopefully they're straightforward, easy to follow. There's only a couple of instructions we actually need from that. And then you can generate an entire website from the comments. We will look at that Tuesday. No homework's actually due till next Thursday. So, but basically it has to do with the comments we put in. It will use docstring instead of the hashtag type comments. Documentation, and under comments, make sure you install PDoc3, and then this is all you need, PDoc-HTML, and it, the file where you're going to output the HTML document, a folder to put the website in, and then the path to the script name. Or all the script names, that's for a single file. --HTML will work. The easiest way, what I usually do, is actually navigate to the folder where the package is and type pdoc-HTML. So in this case, if I go back to idle and add some comments in it, I'll add a doc string instead of a regular comment. This is a quick example. Running out of time. We'll see this again on Tuesday. So put something on there, and I'll save that. Running it's still going to same. All it does is say hello world. Nothing fancy there, but I think terminal's still, and yeah, so terminal's still in the same thing. So if I put that pdoc command, remember our command is pdoc, but make sure you install pdoc3 --HTML, and then doc means look at the folder we're in. Uh-oh. Well, that just worked. Why didn't that work this time? Oh, probably requirements thing. Let me try this. pdoc-HTML. Really not sure why that was doing that. It might be misreading something. I'll try this one more time. It's just not cooperating. We'll get back to that Tuesday. That should generate an entire website from the comments. But I have no idea what this error message is about, because this one does not look at the modules. So I don't know why it's doing that. Because it runs, the module's fine. I don't know why this thinks it can't find that module. So I'll deal with that later. We'll see that, but that's something that should generate an entire website. Let me change this real quick, just so we can see it work somewhere. I'll clear that out of there. There we go. So I ran it, you see some other stuff. And now if I go to that folder, not quite sure what was happening there, but you'll see it created this folder called HTML. And inside of that, we have a website with all of our reference materials. So there's only one thing in there in this case, but you can see that comment we put in ended up right on the website. Nice kind of set up. We'll see that in more detail Tuesday, and I have no idea why that was trying to read the modules. I'll figure out what that's doing. It shouldn't have done that. But all kinds of errors tonight. Those happen. We just have to work with them and move on. But I hate when they happen when we're running short on time. I meant to finish about 15 minutes ago. That went a little bit longer. Does anybody have any questions about the stuff we talked about this evening? So mostly stuff related to Python and getting our manifest ready there. I come back here. That new syntax in the new syntax in Python 3.10 that a whole bunch of us have been waiting for decades. We're very excited to see. Everything else new in 3.10 is much further than we'll get in this, further than we're likely to get in this class, unless you need it for your project. Somebody needs it for their semester-long project, I'll make sure and cover that stuff. Or if there's a new thing in 3.10 that would be better for your project, I'll make sure and cover it. Otherwise, I guess that'll be it for this evening. There's still 20 minutes of lab time. I was trying to shoot for 30 minutes of lab time. Any questions? I assume that means no. To the question that was asked the other day about the access code to the author's companion site, my emails are getting passed around the state and everybody's referring to somebody else. So yeah, I've contacted people in Indy and Evansville and Lake City. So far, that's who I've heard back from, and everybody. Thus far, everybody's just referring to somebody else. So I'm guessing that means there might not be a solution. That's my first guess on that. We will address that. There won't be, don't worry about any late penalties or anything on that author's companion site. There were some really good questions in there. Daniel Lang writes great books. If you look for that author's by name, you'll see books for all sorts of programming languages, and he writes they're all really good. So he writes really good quizzes too. That's what those go to. But don't worry about those points. Hopefully we'll see those good questions that he put together. And as soon as I get an answer for that, I will let you all know how to access the author's companion site. But I seem to just be getting, when I get a reply to the email, it just refers me to somebody else. As far as, so I have a feeling that's going to continue on, and then once it gets back around to somebody that I've already referred to, I'm just gonna be like, okay, yeah, nobody seems to know the solution, but it hasn't got all the way around the circle yet, so I'm still looking on that. Otherwise, you all have a great weekend. If you have any questions, let me know. I will see you on Tuesday, and we will see that the PDOC thing work properly, so we get a nice looking website out of it instead of that quickly rushed one. That script breaks will make things a lot easier. Y'all have a good weekend. I'll see you on Tuesday. I'll fix those errors on the computer. I think I'll do a factory reset.